Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning in. Today we go through equations with the pronumeral on both sides. And remember, the pronumeral is just the letter for which you're trying to solve. So we are going to look at equations like this. You might have one that's 2x equals 3x minus 5. Okay? So how do we solve this? Well, we'll get to the solving in a second. Firstly, what we need to do is we need to understand our goal. Our goal is the same. Even though x here is on both sides of the equation, what we want to do is find a value that we can substitute for x here and here that makes the equation a true statement. So the solution to this happens to be x equals 5, and that's because if I change x to 5, I get 2 times x, which is 5, equals 3 times x, which is 5, minus 5. Now this is a true statement because this equals 10 and this equals 10. So our goal here is the same. We just have to do an additional step that we're not used to. So when you're trying to solve an equation like this, what you must do is first get the pronumeral, so whatever the letter is, A, B, C, X, Y, Z, whatever it is, on one side of the equation. I sort of mentioned this last video. So what I was saying in the last video was that if x is in more than one spot, you need to first get it to one spot. Of course, you have to do that. That's the only way we know how to solve equations properly. So the way you normally do this is you subtract the pronumeral, and there should only be one, so you subtract the pronumeral with the lowest coefficient. So coefficient, remember, means number in front of. Once you've done that, and x is in one spot by itself, you just solve normally. Exactly the same way we've been doing for the last few lessons. I will point out, though, that sometimes that will involve expanding brackets. So let's look at our equation up here. So we have 2x equals 3x minus 5. So what I'm saying is we're going to subtract from each side of the equation the pronumeral with the lowest coefficient. So that's this one here. Because this x only has a 2 in front of it, the coefficient of this term is 3. 2 is lower than 3. So what I do is I subtract 2x from both sides. So 2x minus 2x, they cancel each other out. That leaves us with 0 on this side. 3x minus 2x is just x. Note that this term and this term are not like terms. We can't do anything with them. We can't subtract them. We can't add them. So the negative 5 stays exactly as it is. We do not change it at all. And once you've got into this spot here, you know how to solve this. This is easy. We undo what's been done to x. So instead of subtracting 5, we add 5 to both sides, and we end up with 5 equals x, or x equals 5, which is what we got over here. And we've already checked that this is the solution. All right, let's have another look at some examples. So let's say we have 7x minus 8 equals 5x plus 20. Okay, so the goal here is the same. What I want to do is I want to subtract the x, because x is the pronumeral here. I want to subtract the x with the lowest coefficient, the lowest number in front. So I have an x term here, an x term here. This one has the lowest coefficient. So I'm going to subtract 5x from both sides of the equation. So 7x minus 5x gives 2x. I can subtract them because they're like terms. I haven't done anything with the negative 8. So that equals, so 5x minus 5x is just 0. So I'm just left with 20 on the other side. That's the hard part done. You know how to solve it from here. We undo what's been done to x. So we're going to add 8 to both sides, and I get 2x equals 28. And then we're going to divide each side by 2. And so the final answer is x equals 14. Again, I can check I'm right by substituting x equals 14 into the original equation. So into the original equation, I get 7 times x minus 8 equals 5 times x minus 8. So is this a true statement? 7 times 14 is 98, minus 8 is 90. 5 times 14 is 70, plus 20 does equal 90. This is a true statement. 90 does equal 70 plus 20, so I know I've got the right answer. We need to look at just one more example now with brackets. So similar to what happened last lesson, if we've got a pronumeral on both sides of the equation and there's brackets, we need to expand the brackets first. So let's say we have something like this. 2 times 2x minus 9 equals 5 times 3x minus 11. Let's do this one here. Not an easy one to do. Now again, we have x's on both sides of the equation, but before we get to a point where we can subtract the x with the lowest coefficient, we need to expand the brackets, just like we did last lesson. So 2 times 2x is 4x. 2 times, now this is a negative 9, gives negative 18. So I've expanded the brackets on the left-hand side using the distributive law. On the other side, 5 times 3x is 15x. 5 times negative 11 is negative 55. Now this is like equations that we were doing in previous examples. I want to get x on one side of the equation. I do that by subtracting the one with the lowest coefficient. So I'm going to subtract 4x from both sides. So 4x minus 4x is 0. So I'm just left with negative 18 on this side. And that equals 15x minus 4x is 11x minus 55. You know how to do it from here. Now we've got the x's on one side, so I want to get x by itself, so I'm going to add 55 to both sides. So then I get negative 18 plus 55 is 37 equals 11x. So to get x by itself, I need to divide by 11, because that undoes timesing by 11. So x equals 37 divided by 11. It's not a whole number. I can leave it like that. Or if you like, it's 3 and 4/11ths. Or if you like, you can round it, so it's approximately 3.36. Okay? So again, I can check my answer by substituting into the original equation. You might want to use a calculator for this. So I just go 2 times by 2 multiplied by x minus 9. So that gives me 2 times by 74 over 11 minus 9. If you put that in your calculator, you'll get minus 50 over 11. Now that is supposed to be the same as this. If I get 5 times by 3 by 37 over 11 minus 11, if you put that into your calculator, you'll get 5 times negative 10 over 11, which is exactly the same thing. So I got both answers the same, both numbers the same, if I substitute in x equals 37 over 11. I know it wasn't an easy number to work with, but we've got to get used to it. The solution to equations is not always a nice whole number. All right, thank you for tuning in. This has been the luckiest maths teacher in the world. Have a great day.